But we know here that the slope is equal to 1/4 and the y-intercept, this is the slope, and the y-intercept is equal to, so y equals 3. Okay, and then write the equation in slope-intercept form. Well, slope-intercept form is y equals mx plus b. So I get y equals, I know the slope is 1/4. I multiply by x. That x is not in the denominator. Do not write it as 1/4x. It's either 1/4 times x or x/4. Either one of these is correct. This is incorrect. Okay. Plus b. Well, my y-intercept, actually, this is supposed to say b. My y-intercept, which is b, is equal to 3. So I have plus 3. And that is the equation in slope-intercept form. Okay. Now, just for the heck of it, since I know that's the y-intercept, and I know whenever I have a y-intercept, the point that goes with it is x equals 0, y equals 3. So if I want to put that into point slope, I can just use my my values, right? I know I have a point and I have the slope. So I can say y minus y1, which is 3. So let me write the equation. Y minus y1 equals m times x minus x1. So we have y minus 3 equals m times x minus 0. So I have y minus 3 is equal to 1/4 times x. I add 3 to both sides, and I get y equals 1/4 x plus 3, which is exactly what I got the other way. I would get a different value if I didn't have x equal to 0. I mean, I would get the same equation when I added things together, but this was pretty easy because I didn't have anything to add the 3 to. So again, this one just happens to be exactly the same in point slope and slope intercept. Oh, we talked about the, yes, I'm sorry. So we went past that because we were on standard form of an equation. And I said, don't forget the standard form always has to be integers, such that a and b are not 0. So for example, find the equation of the line passing through those 2 points. And this is probably where we stop. Write the equation in point slope form and slope intercept form and standard form. So first thing we have to do is, one thing we do not have is the slope. So step 1, we're going to find the slope, which is equal to m in our equation, which is y2 minus y1 over x2 minus x1. And again, I'll call this 1 and I'll call this 2. So I get y2 is -4 minus y1, which is 3, divided by x2, which is 2, minus x1, which is -1. So I get -7 divided by 2 minus -1 is 2 plus 1, or 3. So now I know my slope, okay? Now, that was the most important part. Now, let's do point slope. And it doesn't matter which point I pick. So we'll pick point 1, okay? But you could pick point 1 too. It would, it be the exact same thing. So if I put it in point slope is y minus y1 equals m times x minus x1. So I have y, this is point slope. So I have y minus, I'm going to use 0.1. So I have y minus y minus 3, because y1 is 3, equals m. Well, we just found out the slope, times x minus, and x1 is -1, which changes this to a +1. So this is the equation in point slope. So here's one equation. This is my point slope equation. Okay. Now, I don't know what the intercept is, do I? And what we're going to do is we're going to take our point slope formula, our point slope equation. Get everything. Let's see. Okay, so I have y minus 3 equals -7/3 times x plus 1. This is point slope. But now I want to change that to slope intercept. Well, remember, slope intercept is y equals mx plus b. So basically, to change it, I really just need to solve for y, because notice on this side, all I have is y. So I can start with y minus 3 equals -7/3 times x plus 1. And then I can add 3 to both sides, right? And then I have y equals -7/3 times x plus 1 plus 3. But I'm still not in slope intercept form, because look at what it should look like. So what I'm going to do is distribute that 7/3. Where that it's coming from, okay. So I have -7/3 x minus 7/3 plus 3. So I just have to add. So I have minus 7/3 x, that's complete, but I'm going to change 3 to have a common denominator here of 3, so that makes it 9/3, right? So I have minus 7/3 plus 9/3, which is going to equal -7/3 x. And then I have -7 plus 9 is plus 2/3. So my slope intercept form is y equals -7/3 x plus 2/3, right? Because our slope was -7. Yes, that worked out well. This is our slope intercept, where our slope is now -7/3, which it always was, but now we know our y-intercept, which is b, is 2/3, or if I want to know what the point is, x is 0, y is 2/3. That's in order pair form, okay? So I went from point slope to slope intercept, and now the last one we have to do, hold on. Okay, so let's go back and grab, which one do we want? I think I'm going to start with my slope intercept form now. I'm going to grab it. Okay, so -7/3 x plus 2/3. -7/3 x plus 2/3 is equal to y. So this is where we're starting. And standard form standard form is ax plus by equals c. So if I look at that, what I first have to do is I have to get my x and my y to the same side, and then the other side of the equation is just c, which is a constant. So I'm going to add 7/3 x to both sides, and I get 7/3 x plus y is equal to 2/3. And all I did is I moved the slope part to the other side. Now, remember I said that a, b, and c have to be integers. Right now, a is equal to 7/3, b is equal to 1, and c is equal to 2/3. Only b is an integer at the moment, right? Well, that means what I have to do is I have to get rid of that denominator. And luckily, it's the same denominator on both sides. So what I can do is I can multiply both sides by 3. I distribute, so I get 3 times 7/3 plus 3y equals 3 times 2/3, right? Let me put a little line here. Well, always simplify before you multiply. This 3 cancels with this 3. I've lost my x here. This has got an x. So I get 7x plus 3y equals, and again over here, this 3 cancels with this 3, and I get equals 2. And now, as you can see, it's in standard form, where a equals 7, b equals 3, and c equals 2, which is standard form, and a, b, and c are all integers. Okay, so that basically takes care of the 3 different ways we can write an equation of a line. Mostly you've probably used slope-intercept. Now we have point-slope, which will be very handy, and you will actually use this more if you're moving on to methods of calculus. The point-slope is usually used more. And then we have standard form. Okay. And here's the work I did for something, and for some reason it showed up here. Let's see if I can erase it. I'm not really actually sure, because when I lost my computer, yeah. You know what? To tell you the truth, this actual slide is very unhelpful. I wouldn't use it, because if you can see underneath the other things here, and I know I can't erase it. I think it saved it when my computer shut down. So it's telling you like the slope is equal to negative a over b, but this is all memorized. Don't ever memorize things like this. If you want to go from, if you're given something in standard form and you want to put it into slope-intercept, well, let's say I'm given, let's go back to the equation that I had before in standard form. So we started out and we found, oh, here it is. So here we found slope-intercept. And again, I think that this is the easiest place to start. So we have y equals negative 7/3 x plus 2/3. I want to start with my equation in standard form and not use all these equations. So standard form was 7x plus 3y equals 2. Yeah, this is terrible. So it was 7x plus 3y equals 2. So let's start there. 7x plus 3y equals 2. And here it says the slope and y-intercept form of a line given in standard form. So I'm being given this in standard form. Okay. And again, really don't memorize all that stuff. If I want to change standard form to slope intercept, which is y equals mx plus b, what I need is to solve for y, because it has to be y by itself, right? So I start out, I'll do it in another color. So I start out with 7x plus 3y equals 2. And now I'm going to subtract 7x from both sides because I'm solving for y. So I get 3y equals minus 7 equals minus 7x plus 2. And then I'm going to divide everything by 3 because, again, I want to solve for y. And I get y equals negative 7x over 3 or negative 7/3 x, whichever way you prefer to look at it. And now we've changed it from standard form to slope intercept, because that's what we got for slope intercept. I'm afraid if I go back to there, it's going to show weird. Yeah, but there it is actually at the top right here. Y equals negative 7/3 x plus 2/3. Y equals negative 7x over 3 plus 2/3. Okay. Oh, I see. It saved that thing on every slide. Okay, so here's what I'm going to do. I know what slide we're on. I'm going to get a blank one because I think that's going to show up everywhere. Okay, so now it says find the slope and y-intercept and sketch the line. So this is in standard form. And since what we want to do is find the slope and the y-intercept, the easiest thing to do would be to put it in slope-intercept form, which is y equals mx plus b, right? And to do that, again, we solve for y. So the first thing I'm going to do is I'm going to subtract 3x from both sides. It's going to cancel, and I end up with minus 2y equals minus 3x plus 6. And now I'm going to divide everything by negative 2. And then these cancel, and I get y equals, well, I have a negative 3 divided by a negative 2, and a negative divided by a negative is a positive. So I have 3/2, that's my slope, times x. And then I have 6 divided by negative 2, which is negative 3, so minus 3. Okay, so that is my equation in slope-intercept form. Now, I know many of you just make tables, and if that's how you want to do it, it's okay, but I'll show you, hopefully I'll show you an easier way to graph this. And then here's how I would graph it if this was my problem. So first I would have, you'll have a graph to graph it on. Okay, so we have 1, 2, 3, and so on. -1, -2, and we're just 1, 2, 3, -1, -2. Actually, I think I missed. There's one above that. So this would be -1, -2, -3. Okay, so let's see what to do. Now, here's how I would do it. I first look at my y-intercept, and I can see here that my y-intercept is equal to -3, right? So I can plot the point whenever I'm looking for my y-intercept. X is 0, 0, -3, and 0, -3 is right here. And I know that that's a point on the graph because that is actually my y-intercept. And in my opinion, the easiest way to graph this is instead of plugging in numbers, I mean, we're just trying to make straight lines here. So you only really need 2 points, and you connect those 2 points, you have a line, right? So my slope is 3/2, which is equal to the rise over the run. So here's what I would do. I would say, okay, well, there's 1 point, and I'm going to go up 3. 1, 2, 3. So now I've gone up 3. I'm at the origin, and now I go +2. So I go to the right 2, and I have another point here. And if I wanted a third point, I could do the same thing again. I can start at that point and go up 3, which would land me here, and over 3, which would give me 5, 3, 4, 5. So my next point would be here, because I'm going up 3 from the last point, which was 2. The last point was here, 2, 0. And if I add, so remember it's rise, which is y. So if I add 3 to 0, I get 3 for y. And if I add 2 for x, I get 4. And that's what I said it would be. 1, 2, 3, 4, 0. That's not what I said it would be. Let's see, 3, and I add 3. No, I add 2. Yeah, I add 2, so it would be at 4, 3. 1, 2, 3, 4. I just have a dot in the wrong place. So 1, 2, 1, 2, 3. And then notice all these, if it was to scale and I really had a perfect drawing, I can keep doing that because the slope is that, and it's a constant slope, so it'll keep going up in that direction. And then I think I left, yeah, so here I left our nicer picture. We noticed we started out here. We found the slope is equal to 3/2, which is what we found our slope is equal to. And they found the y-intercept is equal to -3, which is what we found our y-intercept equal to. And then again, we just plot it. And you can see here, they're rising 3 and then run 2. And then that's where they get these 2 points. This is the y-intercept, and this is the next point if you just count. Okay? So this is a much easier way to graph something. Now here, notice it says, sketch this line by plotting intercepts. So this is in standard form. And since we're plotting intercepts, it's really easy to use that standard form to plot intercepts, because remember, if I want to know what the y-intercept is, I set x equal to 0. So I have 2 times 0 minus 5y equals 8, which gives me -5y equals 8. +8, yes. And then I divide both sides by -5, and I get y equals -8/5. And that is my y-intercept. I do my x-intercept. When I do my x-intercept, y equals 0. So again, using the exact same thing, I have 2x minus 5 times 0 equals 8, which means really I just have 2x equals 8, which means if I divide both sides by 2, I get x equals 4. So now how am I plotting this? I'm plotting just those 2 points. So if it says by plotting intercepts, you actually have to plot the intercepts. So my x-intercept is x equals 4. X equals 4 is right here as an intercept. And my y-intercept is 8/5. So 10/5, and that's negative, so I'm actually going down. So 10/5 is -2, so it's between 1 and 2. So let's see, I'll say it's about right here. And then now that's my line. So sketch the line by plotting intercepts. I've plotted my two intercepts. I have 4, 0, and I have here 0, -8/5. And that's how you do it. So if it says by plotting intercepts, you have to plot those 2 points. If you plot other points that work, you'll still get it wrong, even if it works and it looks exactly like the same line. And that's a nicer version of what I just did. Okay, so we have our x-intercepted 4, 0, and our y-intercepted 0 -8/5, and we connect the dots. Okay, and then we're almost done now. And I'm really sorry about all the trouble I've had with my computer. But so if we want to graph a horizontal line, so remember, we have y equals mx plus b. I can do this for the horizontal, not so much for the vertical. So y equals mx plus b. If I want a horizontal line, which is what you see here, well, the slope is the measure of the incline of the line, right? Like if you have a slope, it's either going up or it's going down. But if you have a slope, it's not going to go horizontal unless my slope here is going to have to equal 0. So if I have any equation, notice if x equals 0 or m equals 0, not x, if m equals 0 right here, that's going to go to 0 and I just get y equals b. Okay. Now I can't really show you the exact same way for the x. It's a little different, but x, the slope is undefined. Because if we say y2 minus y1 over x2 minus x1, notice my x's are the same, a and a, whatever it is. If it was 1, it'd be 1 and 1. So I would always get 0. So that would be some number over 0, which is undefined. So if you're asked for what the slope of a vertical line is, it's undefined. Horizontal line is 0. But remember that y equals b gives us the horizontal, because basically it's saying if y equals b, right, then it doesn't really matter what value x is. So if x equals 1, let's say this is 1 right here, then y is going to still equal b. If x equals 2, then y is still going to equal b. If x equals 3, y is still going to equal b, right? So it doesn't really matter what my x values are. The y values are staying constant. So when I connect those dots, I get a horizontal line. And the same thing is true for the vertical, right? So it doesn't really matter what my y value is, because it's not even part of this equation. So if I say y equals 1, there's a dot, y equals 2, y equals 3, and so on. So we can see if we connect those dots, we get a vertical line. So let's do our final equation, our final problem. Find the equation of the horizontal line passing through this point. So a horizontal line, remember, has a slope of 0. So m equals 0, which means y equals b. I don't really care about what the y-intercept is, because all the y values are going to be the same. If it passes through the point -1, 3, then A has to be y equals 3, because every point along that horizontal line is y equals 3. And x can be anything, but y is always 3. Okay, so you can see that's this blue line right here. Y equals 3, because we're looking for the horizontal. Well, let me see how to write this. So you know we're looking for the horizontal line, which is always y equals b. Yeah, I don't know what else to say about that. And then for b, well, now we have the slope is undefined. So I can't really use my slope equation. That's why I'm saying I can't really show it to you exactly the same way, since it's undefined. But I'm always going to get the equation x equals whatever the x value is. Let's call it x1, and we'll call this x1. Okay, so here, if I want to know what the vertical line looks like, vertical lines are always x equals, because it's going through every value of x that's the same, and we just use the value that's there, which is -1. Because if it's going through -1, 3, which is the point where they both are touching, so the blue line and the red line are both intersecting at -1, 3. So again, x equals -1 gives me the horizontal line at the place where that point is, and y equals 3 gives me the horizontal line that goes through that point where, the point I'm talking about is this one right here. So that really concludes this lecture. If you need any help again, please let me know. And thank you for your patience. Have a good one. Bye-bye.